We are doing 2-6 today, which is proving angles congruent. And if you recall back to, I think it was last chapter, or was that the very beginning of this chapter? I think it was last chapter. We talked about vertical angles. It was definitely last chapter. There's what's called my hand keeps getting in the way. There's a theorem. It's called the vertical angles theorem. And I told you about it last chapter, but I said I'll teach you more about it later. Do you remember what I told you about vertical angles last chapter? So vertical angles look like this, right? Angle 1, angle 2, angle 3, and angle 4. Which ones are vertical angles? 2 and 4, or 1 and 3, right? So you have vertical angles. Vertical angles theorem says that vertical angles are what? Do you remember? Nobody remembers what I told you about vertical angles last chapter? Not opposite. Congruent. Okay? So that's what the vertical angles theorem says, is that angle 2 is congruent to angle 4, and angle 1 is congruent to angle 3. Okay? So they will always be the same measure. Always. It is not an option for them not to be. Okay, that's the vertical angles theorem. So if I told you that we have this setup, and I said, what is the value of x? With this picture. If this is 2x plus 21 degrees, for that angle, and this is 4x degrees for this angle, and I want to know what is the value of x, how would you find it if we know vertical angles are congruent? Angelina, you just set them equal to each other. Okay, so whenever you're solving for vertical angles, you're always setting things equal. So that would be 2x plus 21 equals 4x, and then you just solve. So take away the 2x. So you get 2x equals 21, divide by 2. So x is 10.5. So what if I wanted to know the measure of the angle? What do you do? Angelina knows. You just plug it back in, right? You take your x and you plug it in here, or you take your x and you plug it in there, right? Find the measure of the angle. So 4 times 10.5 would make that a 42-degree angle. Okay, so if they ask you for the angle, plug it back in. If they ask you for x, you don't have to plug it back in. Questions on that? Okay, then we're going to prove that, oh no, I'm not going to do a proof of that one. I'm going to give you a different proof right now, okay? Any questions on vertical angles? Yeah, Aaron.
So we have to plug it in before we plug it into 2x plus 21?
They should be the same, so you shouldn't have to plug it into both. It's a good idea to plug it into both just to double check that you got the right answer. But yeah, you don't have to plug it into both. This one you didn't technically have to plug it in at all because they just asked for the value of x. But I was just showing you if you wanted to take it a step further, plug it back in. Okay, Devin. How did I get the what?
No, I didn't get. So you know, if I put example 1.
Yeah.
I can. That's fine.
Okay. Okay, so we're going to do a proof for example 2. Can I go now, Devin?
Yes.
Okay. Example 2, you have a given. Remember, every proof they're going to give you a given. So this one, it's angle 1 is congruent to angle 4. And they're always going to ask you to prove something. So in this one, they're asking you to prove that angle 2 is congruent to angle 3. And they're always going to give you a picture, right? So here's your picture. So if this is 1, 2, 3, and 4, okay? We're trying to prove that 2 is congruent to 3, and all we know is 1 is congruent to 4, okay? So where do we start? What's your first step? Given, right? So I'm going to say I know angle 1 is congruent to angle 4. Apparently we don't want to do a tilde here because it is given, right? Free point. Take the free point, please. Anyone see what I could do next? Okay, so I hear both options. You could either say angle 1 is congruent to angle 3, or you could say angle 2 is congruent to angle 4. Why? Why? They're vertical angles, right? So if I say angle 4 is congruent to angle 2, you say because they're vertical angles. Okay, so technically that's the vertical angles theorem that says vertical angles are congruent. Okay, so I know 1 is congruent to 4. I know 4 is congruent to 2. So what could I say next? Knowing these two things, what does that lead me to? If 1 is congruent to 4 and 4 is congruent to 2, then 1 is congruent to 2. What is that property? It's like the law of syllogism. Okay, you could say substitution. Here's the thing. Substitution and the transitive property are very similar. So you can kind of interchange them a lot of the time. Do we need to move? Okay. Shift your desk over a little. Stop sharing food. Stop chatting. Just listen. So what you're going to say here is the transitive property, but if you told me substitution, I wouldn't mark you wrong because technically you are substituting for the 2 in place of the 4, okay? So transitive and substitution, very similar. Okay, so we said 4 congruent to 2 vertical angles, so 1 is congruent to 2 by the transitive property. Then we're going to go back and say, well, if 4 is congruent to 2, we also know angle 1 is congruent to angle 3. And how do I know 1 is congruent to 3? Because they're vertical. Okay, here's the thing. When the order doesn't matter, like in this one, the order didn't matter. I could have done 1 and 3 first. I don't care if you take this step and just lump it with that step because they are the same property, so they'll have the same reason. That's okay. If you want to kind of take that little shortcut, that's fine, okay? So 1 is congruent to 3 by the transitive property, but now here's where we finish it off. So if 1 is congruent to 2 and 1 is congruent to 3, then what? Then 2 is congruent to 3 by, what is that? Transitive again. That's the transitive property. And notice that is that, right? That's what they asked us to prove, so we're done. Okay, so transitive property shows up a lot in proofs in general. Keep an eye out for that, and you'll save yourself a lot of time. Any questions on that one? Okay, just a reminder. I told you yesterday, but I'm going to tell you again just to make sure you're clear. You will never have to do a paragraph proof. Okay, so if the book asks you in the homework to do a paragraph proof of something, you say, nope, I'm going to do a 2-column proof, and you just give me the 2 columns, okay? I will not make you do a paragraph proof. Okay, 2 theorems for you. The first one is called the congruent supplements theorem is the first one we're going to do. Okay, and then there's also the congruent complements theorem, which we'll do next. But here's what it says. if two angles are supplements of congruent angles or the same angle, then they are congruent. Those two angles will be congruent. And I'm going to draw you a picture of this and show you in more like numerical form what this is. If you want to write it out in words, you are welcome to do that. It's in the book, but I'm not going to write the words out. I'm just going to give you the pictures. So if this is 3 and this is 1 and this is 2, the congruent supplements theorem says if the measure of angle 1 plus the measure of angle 3 equals 180, and the measure of angle 2 plus the measure of angle 3 equals 180. Okay, so if this stuff is true, then we can say the measure of angle 1 is equal to the measure of angle 2. Okay, so notice 1 plus 3 equals 180, 2 plus 3 equals 180. These two have to be the same because those two are the same and they still add up to 180. Okay, so that is the congruent supplements theorem. The angles are the same if they add up to 180 with the same angle. Okay, and then there's also the congruent complements theorem. So congruent complements theorem. Any guesses what that one says? Same thing, but 90 degrees, right? So if I have angle 1 and angle 2 and angle 3, that's not drawn to scale, but you'll get the idea. So if I say the measure of angle 1 plus the measure of angle 2 is 90, and the measure of angle 3 plus the measure of angle 2 is 90. Okay, so if those two add up to 90 on both sides, then we can say the measure of angle 1 is equal to the measure of angle 3. Okay. Questions on that? Okay, kind of the transitive property there, right? There's another theorem that says all right angles are congruent. Short and sweet, right? Any right angle that I see. Doesn't matter what it looks like. If it is a right angle, it is congruent to every other right angle. Okay, so all right angles are congruent. Not going to even write that one out. And then there's one more theorem. It is Theorem 2.5. You don't need to worry about the number, but it says this: if two angles are congruent and supplementary. Okay, if two angles are congruent and supplementary, then they're both, any guesses? Congruent and supplementary. So supplementary, they'd form a line. They're right angles, right? If they're going to be congruent and supplementary, the only option is that they're both 90-degree angles. Okay, so they're both right angles. If they are congruent and supplementary, they're both going to be right angles. Okay. So a proof of this would be example 3. If we are given that angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary, and they ask us to prove angle 1 is congruent to angle 2. And here's the pictures they give. Angle 3 angle 1, angle 2. Okay, so they're not telling us the measure of anything, but they're asking us to prove 1 is congruent to 2. So what we're doing right now, you can't use the congruent supplements theorem for, because that's what we're trying to prove, is that the congruent, or sorry, yeah, supplements. Did I say supplements or complements? Congruent supplements theorem is what we're trying to prove. So you can't use that as a reason. From here on out, once we've proved it, you may use it as a reason, okay? But right now, you can't use it as a reason because we haven't proved it yet. So we're gonna prove this. What's the first thing you'll say? The given. Now here's the deal, okay? On a quiz or a test, I am totally fine with you doing this because sometimes the given's really long. I don't need you to rewrite the whole thing. You can just draw the arrow like that. It's hard to do that in the homework because you don't have it written in front of you. But for the sake of your notes, for the sake of a quiz or a test, you can totally just circle the given, draw an arrow to where it should be, and then write the word given, okay? So that's the first thing that we know. What can we say? Since they told us they are supplementary, what do we know? They add up to 180. So we're going to say the measure of angle 1 plus the measure of angle 3 equals 180. And the measure of angle 2 plus the measure of angle 3 equals 180. And what's the reason for that? Not substitution, supplementary, right? That's just the definition of supplementary. In the given, they told us they're supplementary. Well, that means that they have to add up to 180 then, right? Okay, so then from there, I can say what? If they both equal 180, what is true of them? They equal each other, right? So we can say the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. Why can we say that? Which property is that? Transitive, or you could say substitution. We'll go with transitive. Okay. So basically we took out the two things that were the same and we set what was left equal to each other. That's the transitive property, right? If A equals B and B equals C, then A equals C, okay? So then your last step right now is the measure of angle 1 equals the measure of angle 2. How do I get from this to that? Subtraction, right? I just took away the measure of angle 3 on both those sides. So you would say subtraction property and this is what they asked us to prove, right? 1 congruent to 2. So you're done. Questions on that? Okay, that